Alright, so back to the continuation of what we were supposed to finish on Friday. It's going to take a while, so just bear with me. So it is too much work to do such work for complicated functions. We are generally interested when the particle is stopped or when it has no acceleration. So we are also interested in the object is speeding up or slowing down. Realizing that an object's velocity, so we're talking about velocity here, is either positive or negative or zero. So when it's positive, we're moving to the right, negative, we're moving left, and when it's zero, it stops. And an object's acceleration is either positive, negative, or zero, which means that we're moving at a constant speed. So we can now use a chart to determine all of the possibilities of the object's motion as if you were looking at it from above. So let's take a look here. When my acceleration is positive and my velocity is positive, that means I'm moving to the right and I'm speeding up. When my velocity is positive and my acceleration is negative, that means I'm still moving to the right, but I'm slowing down. Okay, I'm going to put right here. When my acceleration is zero, but my velocity is positive, that means I'm moving to the right at a constant speed. So move right at a constant speed. When my velocity is negative and my acceleration is positive, that means I'm moving left and slowing down. So I'm slowing down in the left direction. Okay, and then when both of my acceleration and my velocities are negative, that means I'm speeding up. And I'm going to the left. I'm speeding up in the left direction. When my acceleration is zero and my velocity is negative, that means I'm moving to the left at a constant speed. And when my velocity is zero, that means I stop. So stop, stop, and I stopped here. Okay, so let's look at this example. Example 3, a particle is moving along a horizontal line with the position function, all these numbers here and letters. Do an analysis of the particle's direction, right, left, acceleration, motion, speeding up, slowing down, and position. Okay, so step 1. Step 1 is to find the velocity. Remember, the velocity is the first derivative of your position function. So let's find my velocity function. So the derivative of t squared is 2t. The derivative of negative 6t is minus 6. And the derivative of 5 is 0, so we don't care. Alright, so when is my velocity equal to 0? So I set my velocity to t minus 6 equal to 0, and I get that t equals 3. So at t equals 3, that's when my object will stop. So that's a critical value. I put it on my number line. Okay, and it says make a number line of v of t showing when the object is stopped. Okay, and the sign and direction of the object at times to the left and right of that. Alright, so to the left I have time t equals 2. To the right I have time t equals 4. It says assume t is greater than 0. Alright, assumed. Okay, so let's see. Now I'm going to evaluate that in my velocity function. So when it's v of 2, I get 2 times 2 minus 6. That's 4 minus 6, which is negative 2. So I'm negative right here. That means I'm going to the left. It was 0 here. That means I stopped. And see, let's evaluate it at 4. V of 4 equals 2 times 4 minus 6, which is not 8 minus 6. Let me see, 8 minus 6, which is 2. So that's positive. That means I started moving back to the right. Okay, so step 3, find your acceleration function. Remember, the acceleration function is the second derivative of your position function or the derivative of your velocity function. So v prime of t equals my acceleration function, which is going to be 2. So my acceleration function is 2. Does a of t equal 0? No. Okay, so make a number line of A of t showing when the object has a positive and negative acceleration, scale it exactly like the v of t number line. So I need a 2 here, then a 3, and then a 4. Okay, and then, so it's always positive, all along. Okay, so that's my acceleration function. So what does that mean for my motion? So it says, multiply the signs and interpret according to the chart above. Okay, so negative and positive. So from 2 to 3 to 4, forgot to scale it. Okay, let's see. Let's make it purple. Oops, go away. Purple. Alright, so negative and positive. My velocity is negative and my acceleration is positive. So we are right here. So I'm slowing down to the left. So moving left and slowing down. Move left and I'm slowing down. At 3 we stopped. And we probably turned around. Let me see what happened at 4. At 4, now we're moving to the right and we're speeding up. So speeding up to the right. Yeah, so that meant at 3 I stopped and turned around. So my position, what does this mean for my position? So I have to evaluate all these times at t equals 0, t equals 2, t equals 3, and t equals 4. Let's find out where we were, what position we were at. So using my position function, evaluate all those points. So, let's see, at t equals 0, I was at s of 0 equals 0 squared minus 6 times 0 plus 5. We were at 5. So I'm going to draw 5 right here. That's where I was. T equals 5. Dog. Alright, that's my dog. His name is Potato. He's still barking. Alright, anyway, t equals 2. So let's see, at t equals 2, s of 2 equals 2 squared minus 6 times 2 plus 5. That's 4 minus 12 plus 5. That is negative 8 plus 5, which is negative 3. So at t equals 2, we were at negative 3. I'm going to draw negative 3 right here. So at t equals 2, I was at negative 3. So yes, I did move to the left. Hey, isn't that what we said? All right. So at t equals 3, yeah, 3. Let's see. I got s of 3, which is 3 squared minus 6 times 3 plus 5. 9 minus 18 plus 5, and then that's negative 9 plus 5, which is negative 4. So I'll put it right here, negative 4, and that was at t equals 3. So this is where I stop and turn around, supposedly. All right, let me check out s of 4. That's 4 squared minus 6 times 4 plus 5, so that's 16 minus 24 plus 5. That is negative 8 plus 5, which is negative 3. Yep, I went back over here, so this is at t equals 4. So I went to the left, I stopped, I turned around, made a U-turn, and then now I'm here. Okay? Alright. Okay, so on this example, we're doing the same thing. We're going to follow the same exact steps that we had here, steps 1 through 6. So that we could do another analysis of this function, of this particle, using this function this time. So we're going to analyze the direction, acceleration, motion, and position. So let's see, direction comes from the velocity. Let's find out what it was. Alright, so the first step is to find our velocity function. How do I find my velocity function? Well, it's the first derivative of my position function. Hi, Potato. My dog says hi. Okay, go away. Alright, so the first derivative is going to be 3t squared minus 9, not 9. Okay, minus 2 times 9, which is 18t plus 24, and the derivative of 4 is 0, so I don't need it. Okay, then the next step is to find out where I stopped. So that's, I need those critical values. so I can put it on my timeline, on my number line. So I'm going to set this equal to 0. So when I set it equal to 0, I'm going to factor out that 3. That's going to be 3 times t squared minus 18t plus 24 equals 0. If I divide both sides by 0, or by 3 I mean, I just get t squared minus 18t plus 24 equals 0. That can go away. And so if I divide by 3 I mean, now I factor this guy. So t minus 4 and t minus 2. So I get t equals 2 and 4. Positive 2 and 4. So those are my critical values. I put it here, and I put it here. Then I'm going to test other numbers in between. So 1, 3, and 5. Remember, I just need to know what direction it's going. I know that at 2 we stopped. So it's 0 at 2 and 4 because that's where we stopped. So let's check out our velocity. Oh, let me put a box around this, and in case I forget where my velocity function is. So let me see. So I evaluate velocity at 1, so it'll be v of 1 equals 3 times 1 squared minus 18 times 1 plus 24. And that's going to be 3 minus 18 plus 24. So that'll be a positive number. That'll be negative 15 plus 24, which is 9. 9. So we're positive right here. At 3, v of 3. So it's going to be 3 times 3 squared minus 18 times 3 plus 24. So that's going to be 9 times 3, which is 27, minus 18 times 3. 3 times 8 is 24. Carry the 2. 3 times, that's 54. And then plus 24. So that'll be a number. Let me see. 54. 1 sec. Okay, using my handy-dandy calculator, I got a negative 3. So it'll be negative at 3. And then at 5, so let's see, v of 5 equals 3 times 5 squared minus 18 times 5 plus 24. I'm going to get, let me see, that's 5 squared is 25, 75 minus 90. Plus 24, that's going to give me 99 minus 90 is 9. So a positive right there. Okay, so what does that mean? That means I'm going right, then I stopped and turned around and went left, stopped, and then went right again. Okay, so now let's check out our acceleration. How do I find acceleration function? Well, that's the derivative of my velocity, or the second derivative of my position function. So that's the derivative of velocity is equal to 6t minus 18. Yep, that's it. So my acceleration is 6t minus 18. And now, when does this equal to 0? When does my acceleration equal 0? At t equals 3. So I have a constant acceleration at 3. Okay, so I'm going to use those same numbers as before on my other number line. And we're going to check out what's going on here. So at a of 1, I get 6 times 1 minus 18, which is negative 12. So I'm negative right here. At T2, A of 2, I get 6 times 2 minus 18, and that's going to be 12 minus 18. That's going to be a negative number right here. Then at 4, A of 4 equals 6 times 4 minus 18. That's 24 minus 18. That's going to be a positive number, positive right here. And then at A of 5, I get 6 times 5 minus 18. That's also going to be a positive number, so I'm positive right here. So what does that mean for my motion? 2, 3, 4, 5. What does that mean? So when my velocity is positive and my acceleration is negative, that means I'm moving to the right, but I'm slowing down. When my velocity is 0 and my acceleration is negative, so I'm slowing down to a stop. On the and then it's negative and then 0, so now we're going to start moving in the left direction. So I'm moving to the left in a constant acceleration. Move left at a constant speed. Okay, and then right here is 0, but my acceleration is positive, so now I'm increasing, I'm speeding up. Because I'll stop and then I'm going to start speeding up. Oops, that's what I meant. So I stopped here again, and now I'm speeding up in the right direction. So I turn around here, and I turn around here too. Okay, now I want to find out my position. Okay, so hopefully you guys copy down all this work because now I'm going to erase it. I need room to find out my position at all these critical points in time. Okay, so my position function, which is up here, at s of 0 equals 4. So at time t equals 0, I was at 4. So I'm going to put 0 about here. So, not 0, I meant 4. This is 4 right here. And this was at time equals 0. So we're right here. Okay, then at s of 1, I already did the calculations, mind you. So 1, I get 1 cubed is 1 minus 9 times 1 is negative 9 plus 24 times 1 is 24 plus 4. And that equals 20. 20? Negative 8. Yeah, 20. So I'm going to put 20 all the way over here. So this is 20. And this is time t equals 1. So we're up here. So from 0, it went to 20. Does that correspond? Yeah, it moved to the right. And it's going to slow down because we're going to stop eventually. Let's see. And then we went to 22. Not to 22. Just kidding. At t equals, at s of 2, we get 8 plus 12 plus 4, that's 16, and 8, that's 24. So at s of 2, we get 24. So I'm going to put 24 right here. This is t equals 2. Then s of 3, I get 22. So put 22 in the middle. And this is at t equals 3. Oops. So I turned around, and I'm moving to the right. And then s of 4. At s of 4, I get 20 again. So I'm over here again. This is t equals 4. And then at t equals 5, at t equals 5, s of 5, I get 5 cubed, which is 125, minus 9 times 25, plus 24 times 5, plus 4. Get my handy-dandy calculator, so 125 minus 9 times 25, plus 24 times 25, times 5, plus 4 equals 24. So I'm back at 24 this way. So we turned around and went back to 24. So it did this kind of S thing right here that can't make up its mind. Anyway, so that's that. Okay, so note that the position graph is not like any of the other three graphs. It simply shows the position of the object has with respect to the origin and critical times of its movement by setting DFT and AFT equal to 0. Okay, so that's what we did. That's how we find our position functions, our position graph. Anyway, moving on. So when an object is subjected to gravity, its position function is just given by s of t equals negative 16t squared plus v sub 0 t plus s sub 0, where t is measured in seconds and s of t is measured in feet. V sub 0 is the initial velocity at t equals 0, and s sub 0 is the initial position at t equals 0. The formula is given by s of t equals negative 4.9t squared plus v sub 0 t plus s sub 0 is when it's measured in meters. So I've given this to you guys before. That negative 16t one is when it's measured in feet, and then that negative 4.9 is when it's measured in meters. Okay, so here's our original one. So we can calculate the velocity function. So yes, we can. How? By taking the first derivative. So it'll be negative 32t. And the acceleration function, which is just going to be negative 32, because it's the derivative of my velocity. This is the acceleration due to gravity on Earth. So I don't know if you guys knew that, but we do have an acceleration of negative 32 feet per second. That force is pulling on us because we are here on Earth. Okay? And then if I were to take the second derivative of the function that's measured in meters, if you've taken physics, then you know that we have that negative 9.8 meters per second is the gravity on Earth as well. Okay, that's meters per second, and this is feet per second up here. Okay, that's going to be useful for this example here. So it says when an object is thrown upward and it is subjected to gravity, we are usually interested in how high the particle reaches and how fast it's going when it impacts the ground or water. Let us analyze what these mean. So when an object reaches its maximum height, what is its velocity? You guys know that. When an object reaches its maximum height, what does it do? What does the velocity do? Yeah, it's 0. So the velocity is 0. Right? Because if we're talking about something that's going to move up and then come back down, you guys know that the tangent line here has a tangent of 0 at any maximum or minimum value. And then when an object hits the ground, what is its final position? The final position is also 0. Okay, so if I throw an object, or if I were to kick a ball, kick the ball, goes up to its maximum height, and then come back down and returns to 0. The position is 0 here. Position equals 0. My velocity equals 0 up there. I would never be able to kick a ball that high. It'll probably be more like, no, that's still too high. It'll probably be like this. Anyway, so let's see. So to find the maximum height of an object, we set our velocity equal to 0. And so to find the velocity of an object when it hits the ground, we set the position equal to 0. Very important. So find maximum height, set velocity equal to 0. Find velocity when it hits the ground, set the position equal to 0. So it says, example 5, a projectile is launched upward from the ground level with an initial velocity of negative 112 feet per second. Find the velocity and speed at t equals 3 and t equals 5. So that means that my position, I'm going to use s of t equals negative 16 t squared plus my initial velocity times t plus my initial position. So it tells me I have an initial velocity of 112 feet per second. That's from ground level, so my initial position is 0. Okay, so let me change this now. So now I have negative 16t squared plus 112t. 1 second, I'm getting a phone call. Alright, so that just means, let me see, so my velocity function then will be the derivative of this, which is negative 32t plus 112. So it says find the velocity at t equals 3 and t equals 5. So v of 3 equals negative 32 times 3 plus 112. And that's going to be 96 plus 112 is 16 feet per second. So my velocity is 15 feet per second when time equals 3. At time equals 5, I get negative 32 times 5 plus 112, which is 5 times 2 is 10, carry the 1, 15, 160 plus 112, so negative 160. So that's negative 48 feet per second. Okay? Alright. Any questions? I can't answer them anyway. Haha, just kidding. Anyway, how high will the projectile rise? So remember, when I want to find the maximum height, I'm going to set the velocity equal to 0. So my velocity function is this one right here. So, let's see. So, I'm going to set this equal to 0. Oops, negative 32t plus 112 equals 0. So negative 32t equals negative 112. So t equals, using my handy dandy calculator, that's 112 divided by 32. That's 3.5. So at t equals 3.5, I reach my maximum height. How do I find that maximum height? I'm going to put it back into my position function. My position function is this guy right here, which is this one right here. Sorry, not that one. Alright, so at t equals 3.5, so I'm going to find s of 3.5, and that'll be negative 16 times 3.5 squared plus 112 times 3.5, and using my handy dandy calculadora, that's going to be, clear this, clear, 3.5 squared, that's not what I want, 3.5 squared, so negative 16 times 12.25, so 16 negative times 12.25 plus 112 times 3.5, 196. So it reaches a maximum height of 196 feet. Okay, it says find the speed of the projectile when it hits the ground. So when does it hit the ground? Whenever my position function equals 0. So let's do negative 16t squared plus 112t equals 0. Let's pull out a t. I know a t can come out. Can a 6 come out? 112 divided by 16 is 7. Yes, it can pull that. So I can pull out a negative 16t, and then I can pull out a, so it'll be t minus 7 equals 0. So and then that'll be t equals 0 or 7. So I want it at 7. So I'm going to find my velocity at 7 seconds. So v of 7 equals negative 32 times 7 plus 112. So using my handy dandy calculator, 7 times 32, so it's going to be negative 224, so make that negative, plus 112 equals negative 112. So it hit it with a force of 122 feet per second. That's pretty hard. That means it was falling down, right? Because it's negative. Okay. Okay, and this video is getting way too long, and I still have 1, 2, 3, 4 other examples, but they're all pretty much the same thing. Just remember that when you are finding a maximum height, you set your velocity equal to 0. And when you're finding the velocity when an object hits the ground, you set your position equal to 0. So this is so much more easier now. Remember that the other time when we were finding like S of A minus S of T, and then A minus T, and that was doing the limit process as T approaches A, and you guys were getting all confused, and why am I plugging in A twice, and then I have to plug it in again for T, and that was just super confusing for you guys. Well, now you guys get to use derivatives. So it should be a lot easier now. Text me if you guys need help, and then I will see you guys later. Bye-bye.